Hello and welcome back to the workshop. On this video I thought I would show you something my daughter's been working on, and it's this scaled down model of a 24 pounder brass battering cannon designed by John Armstrong in the early 18th century. My 17-year-old daughter has now gone into her second year of her engineering apprenticeship. She asked me if she could make something in my workshop, so obviously I agreed, providing it involved various machining techniques. She asked if she could make a cannon, which I thought was a good idea. So she spent hours on the internet doing research on cannons and eventually found one she liked. She said she's going to scale it down to the size of a piece of A3 paper, as you can see. So she did a good job of that. So then she started producing some drawings like this one of the muzzle. Producing drawings like this one is another skill that she needs to learn. I thought she did quite a good job of this one. Once the drawings were complete, we cut some material from bar stock and aluminium plate. The first part was making the muzzle from brass bar, which was 40mm diameter and 280mm long, which involved taper turning and the use of a fixed steady. Next part then was making the trails and transoms. The trails are set at an inclusive angle of 2.6 degrees, so that involves some trigonometry to make the transom fit exactly in the correct places. There's three, one in the tail, one in the centre and one at the front. The centre one was used for adjusting the muzzle. On this view you can see where the trail pieces, these two, are set at the 2.6 degrees. Some of the learning techniques she's done include these wheels, which involves turning the hubs and the actual wheels, drilling and reaming the spokes using a dividing head, and also milling these wheel straps, which are produced radially, these, so they were done on a rotary table. Another interesting machining technique is these trunnion straps here. Joe Pye did a very good example of producing these on a rotary table, so she watched that and produced these in exactly the same way, so very good learning technique that. Making the casing was an interesting part for her to make, which is this box, but I must admit she struggled when it came to making the hinges, so I had to help out on that part because it's only 3mm wide, or 1/8 of an inch, and she wanted it to work, so there's 1 inch there and there's 2 inches there. All cannons had steel tyres that were held on by rivets, and also along the trails here. So my daughter used this brass strip here, which is 0.7 thick, to make the tyres, the trail pieces here. You can also see them wrapped around the end of the trails. The modern apprentices are brought up learning CNC machines, which is the way forward for obvious reasons. But I'm a believer in the more manual machining techniques you can learn, the better you'll be in the future. I've had many apprentices over the years working with me on manual machines, and a lot have moved on to high positions in engineering, which I'm glad about. These cannons were very powerful and were used to break any defences before the soldiers went in with field cannons. They were very heavy, usually weighed about 2.5 tons, and required 12 cannoneers to operate them and at least 6 horses to pull them with the limber and travelling forge and caissons and other supplies. Each cannoneer had a specific role to play in firing the cannon, but they all had to learn every role in case one were killed. The cannon would often get stuck in mud after heavy rainfall. In these sort of battles, more soldiers died from hypothermia, disease and exhaustion than that were killed in battle. I'm just glad I wasn't born in these times. Well, there's still quite a bit more work to do on this now. She wants to make a matching limber and other parts, and also mount it on a wooden base. You can see some extra wheels here. Okay, next time she comes into the workshop she's going to be making the limber and the other parts, and she did say she'll allow me to film her doing that so I can make a video of it. Well, I hope you enjoyed this video. It was just something I put on while I'm waiting for the quartz to finish off my clock. So thank you very much for watching, and I'll see you on the next video.